Hi everyone. So today's presentation is by two 3-letter acronyms or 4-letter acronyms. So it's PDG, Paul, Denny, Gouldson. I'll do the first bit, and then Bugs is going to join in and do the demo and talk about the architecture. So as we all know, there are a number of barriers and challenges that are facing Allotrope in its adoption. And if you go on to the next slide, as we've gone on this journey through there, they've kind of dropped into 3 boxes. We have a massive landscape that we're trying to deal with here in terms of the instruments, the models, the makes, just the huge variety of data generators that we have. And each of those come with legitimately their own data formats from history, and then there's a number of vendors that are jumping onto ADF and recommending that someone's there. And then several vendors that are not supporting the ADF format directly yet, and that's just because it takes a while for these things to do and to get out. But the other things that now we're a number of years into Allotrope, into the data format, the standards and the approach, then other things have started to come into play, and those are around the development of the ontologies. So those elements that describe the data, that allow us to aggregate data across different instrument types and vendors into a normalized data view, which then is part of the promise of Allotrope, which is the ability to aggregate that data, look for patterns, do all kinds of cool analytics and integrations. Then our own knowledge and how to do that is evolving, and so there's been some lessons learned there, and some of the things that we'll talk about in our description of what we've been doing. And the other one is then saying, how do we get the data and combine it from applications, not just the instruments, and bring that into the analytical workflow so that we can get to, in some cases, closed loop workflows, but in others, just a workflow from instrument through workflow into application for results publishing or whatever. And so those are the 3 kind of areas that have been hindering and challenging the adoption and the approaches that we're taking. Next slide, please, Bugs. And so as we move on to that, this is the kind of picture of that problem, where we have the huge number of not just instruments that we're dealing with, but also the huge landscape of applications that are interested or require data from instruments to be used and to make them useful. So if you look at at the left hand side here, you've got the well-known big stuff: historians, product lifecycle management, manufacturing execution systems, LES, CDS, those things that we're all familiar with and know that they're collecting data and we need to get data from. But then at the other end, you've got the simple things where people still have workflows, applications, and infrastructures using smaller elements where we're still in Excel, fitting SOPs linked to PDFs, things like that. And then along the bottom, you've got that big landscape of different types of instruments, from very complex, where we're talking about NGS, NMRs, bioreactors, mass specs, HPLs, HPLCs, all the way down to the simpler instruments. But the data is, although it's simpler, may be almost as valuable, if not as valuable. And so this this complex landscape is something that we're all grappling with and trying to find ways to bite off bits of the elephant as we go through. Next slide, please, Bugs. And so when we look at that, and it's complicated by what we've already said, right? We know that we have a variety of data formats, and that isn't going to change in the near future. Some things are known, I think one of those is that not everybody is going to adopt a standard in a short term, and maybe not ever. But we have to be able to work towards getting data from the source systems, their source formats, and moving those into more consumable, reusable data formats and descriptions. So this is one of the big problems that we have, and being able to deploy a solution that can cope with a variety of data formats when we're talking about ingestion of raw data and conversion to ADF. That's a fundamental concern and a fundamental requirement that we have to make sure that we can adapt to, so that we don't kind of lock ourselves into a cul-de-sac. Next slide, please. And so when we move on, we look at this from a, how do I get this into the lab and how do I get it into a delivery mode? It's a constant uphill struggle. And people often think about, well, we can get an infrastructure in and then we can get it going. But then there is the continual monitoring and maintenance of that infrastructure to cope with, how do I bring on new instruments? How do I bring on instruments where their application, the application that's running them changes, or their data format changes for whatever reason? And so thinking about how to make an infrastructure as flexible as possible and as dynamic as possible, but with the ability to be run as a service, is something that Zifo have been looking at and focusing on very much over the last 3 or 4 years. And so next slide, please, Bugs. And so when we look at what can we do, and this is something that that Bugs and the team have been working on for a long time, and thinking and using the best of breed and best of knowledge approach, and that's where the concept of the Lab 4.0 solution has come from. So what is the Lab 4.0? If we move on to the next slide, is something that we can do and we can deliver. So it's introducing that as much as we can. And so when we look at what is Lab 4.0, next slide, please, Bugs, then we look at what have we done. So Cuttle is the part of our solution that really looks at those problems that I've just been talking around the plethora of data formats that the instruments and the applications produce, and being able to take those inputs, apply a standard process to them, leveraging some open framework tools that can support both the tabular and the graph models that we know are important for different types of analysis and consumption. But being able to apply the concept of a library, a connector library that takes the raw data, that can then pull that through, that can allow customers and users to develop their ontologies, to rework those ontologies as their knowledge develops, and apply those to those conversions, and then be able to scale and run this as a resilient solution across many locations and in labs, both in the validated and non-validated environments, as something that are the kind of key requisites and requirements that we've used to drive the framework, and looking at how that's there. And so that ability to deliver that is something that Cuttle is designed to do. And so now I'm going to hand over to Bugs, who's going to take you through what is Cuttle, what does it look like. He's going to show the demonstration and also talk about the fundamentals and the architecture that kind of will really highlight the openness, the scalability concepts, and then the ability to support the different and the wide variety of formats that we know are out there. So Bugs, over to you.
Thanks, Paul. All right. Right, we'll shift gears now and jump into the demo part. Let me come out of the full screen. It's not coming out. Okay. Right. So, like Paul mentioned, this is something that we have looked at delivering as a open framework, something where you could be able to quickly configure. It's extension of what we have demonstrated prior the prior Allotrope Connect events, where we have demonstrated some of the point Allotrope the ADF converter solution. From there, we looked at some of the challenges. We have worked on a number of instrument integration projects apart from the Allotrope ADF part, and that's where what we looked at is there a way that we could offer an open framework that could be quickly adapted, be able to move fairly quick, and then provide the sort of services required to be able to move quickly. That's where the whole solution was evolved, in terms of having a platform where you provide a set of libraries for the different instruments. And a quick preview of it now. So this is basically where we start, and what we are going to show now is basically a Chromeleon file-based conversion. The reason we took the file-based conversion is that's probably the most complex one to compare to other options. So we start here. So this is a Chromeleon file, essentially a purity analysis sample file that we are showing. So this has pretty much all of the information that comes in terms of the sequence, the reports, and the whole audit log. And this is something that we looked at doing the conversion as part of one of the projects that we did. And the whole idea is to be able to convert this entire content from the PDF into a ADF format. So that's essentially what we will show now. Right, so sitting here, I'm uploading the file to the Amazon S3 bucket, where we have a file watcher that's monitoring that folder. So as soon as I upload, in terms of the process, it's pretty straightforward. So we'll show the activity screen, and you will see the file has been already picked and it started progressing. And in a short while, you will see the file being processed completely, right? So what we say is the input source that we are configured. We'll come to the source part shortly. The input file that was uploaded and the corresponding output that got generated. On clicking it, in this case, we are opening it in an ADF viewer. This is more a centralized web viewer that we have developed, where you don't need to install in the individual machines. Rather, you host it in a central server. In this case, the file directly gets opened without being downloaded to your local machine. So that's the overall idea. And we have essentially loaded the data description, the results in the data queue, and also the file that came in was loaded to the data package. So pretty much all the information that came in was loaded into the ADF. So that's the overall concept in terms of how this works from an end user perspective. So how does it work more in terms of the configurable option? For that, I'm just going to switch here. Right. So some reason. Second. Yes, I have to mix up. Right. So this is a high-level architecture in terms of how we have done this solution. Like Paul mentioned, we have a variety of instruments and a number of applications that's out there in the landscape. The whole idea is to be able to provide a configurable solution. So as part of that, it essentially has the three components. The first one is essentially a data integration layer, where we provide an option to configure based on your incoming data. And we have a kind of a unified data format for different instruments that we have kind of adapted based on the Allotrope models. So you essentially transform those incoming data to that model and then be able to map it to the Allotrope data models and the ontologies, right? This is something where we could support both the tabular model as well as the graph model. So that's something we kind of keep it quite flexible in terms of how we want it. We create the libraries and the reference mappings, and that's pretty much how the data flows. Going back to the demo now. Right. So this is the data extraction part. There are two parts to it. The first one is being able to get the data from the instruments or the application. In this case, we support a number of connection options. It could be files, or it could be a direct read from the database through SQL queries, or it could be a REST API call that we schedule, or the other source system could do a REST API call for the purpose of transferring the data. So there are a number of options that's provided out there. This is something that extracts the data first, and then we'll do this connection. So going back to the application, this is where we define. So each incoming file format is defined as a source, and here we have this endpoint. The one that I processed is essentially a file. So we set up a file watcher to a specific directory where the file is arriving. Yeah. So this is the creation of the source, where for a specific type, we provide a number of connection modes, and based on that, you could configure from where to pick the data, and the rest of it is pretty much taken care. You could schedule it or make a call or trigger it. There are a number of trigger options to pass the data and be able to move from that. So that's the first part in terms of setting up the endpoint. The next part, once you have the data, you then need to parse that data and transform it to this unified internal format. It's essentially a JSON format that we have kind of standardized based on the Allotrope model. So the incoming data need to be transformed to the standardized model. And if it's not coming in the JSON format, again, you have to transform it. So this is something where you have a fair bit of work based on the different file formats, the different instrument models that exist out there, where you don't get the support for the ADFs. So what we use is a widely known ETL tool called Talent, where you could set up the parsers and upload the parsing jar file to this. Just going to, so we have the parser out here. So this is the Talent tool. So you could essentially configure the whole processing of data based on a number of components that exist out there in Talent. Even if a component is missing, you could still be able to quickly add a component, maybe use Java or Python and be able to extend it. So that's how we build these parsers. And this is something where we are also building a standard set of library components in terms of the parsers for the different instrument models and the data formats that exist out there. But if it does not exist, you could still go back and be able to quickly build it as long as you have the Talent skill set to build this. And once the file is moved to the standard unified format that we have, then you essentially need to do the mapping to the Allotrope ontology and the model. So that's something. This essentially what we provide is we provide few UI options in terms of doing it from a CMap or doing it from an Excel, where you do the mapping to the Allotrope models for your incoming data. And once you have the mapping done, so this is the UI, you could review the data. So this is the JSON file that comes in where all the terms are mapped, and you essentially it's saved as a mapper. So we have the incoming file that's parsed, and then this mapper that transforms the data. Let's go back. Right. So once we have the whole process done and the linked data gets generated based on the mapping, we then have the ADF libraries that load that incoming data that was semantic annotated from the mapping, and that's loaded into the ADF. So the data is loaded into data description and data queue. There are some internal mappings that ensures you choose which one is data description and which one is results, and that's done. And all the associated files also get pushed into the data package. So that's essentially it in terms of how we have done this. So you have these parser libraries that we build. Apart from that, you could also easily build it with a Talent component. And we have this mapping. Again, we provide the different options for the mapping so that that's something that you could do easily. But as long as it's in the unified format that we talked about, you can also use the reference like ontology mapping libraries that will readily map that data to the Allotrope ontologies and model. So with that, you will be in a position to roll this out to any instrument or application fairly quick. We are in the process of building the connectors for the applications and the instruments and looking to build a large set of library based on that. So that's essentially it. We'll now open it up for questions.
Great, thanks Bugs, and thanks Paul. So I think we have time for one question. Jamie, do you know if we've had any submitted so far?
Yeah, there's two. And I think they're from the same person, so maybe related. Maybe does Talent have specialized adapters for these data formats, or is the transformation custom coded? And will you explain reference mappings in Talent?
No, so the Talent does have only the components. The libraries are being built by us. That's a service that we are offering. So we are in the process of forming a number of partnerships and building the libraries. In fact, one of that you would have seen, apart from the instruments, we have also formed a partnership with Zontal team, and one of the projects we have also directly loaded the data out to Zontal. So we have the connectors across. That's something we build leveraging the talent tool. And as far as the reference ontology mappings is concerned, that's something that we again are building. That part is done by a ontology tool that we have developed. That's not part of talent.
Great, thank you.
Any other questions? Okay,
All right, cool.
I'll stop.
Great. Great. Thanks again, Bugs, and thanks again, Paul.